Hello, hello. Want to make sure that you can hear me. All right. Happy Sunday. Today I'm going to do a sample size calculation for the Pearson's correlation. Okay. So what at the top of the screen, there's a tab for test, and you're going to pick the correlation tab, correlation bivariate normal model. Okay. And then you're going to make sure that this is an a priori, which means that you're calculating it before you actually collect the data. Then I'm going to pick a two-tailed test because I don't know if this correlation is going to be positive or negative. Okay. And then the correlation, let's start with the null hypothesis. So typically at this point, I will ask the client what they believe the null hypothesis is. Typically, the null hypothesis for a correlation is that there's no relationship. Okay, anytime you have a null hypothesis, the language that you use is that there's no relationship or there's no difference. It's always that everything is fine, things are at a particular, we've already previously defined what the answer is, and that's what it is. And so for here, it's the correlation that there's no relationship. So you put a 0 here. For your correlation, your alternative hypothesis is H1, your null is H0. So for your correlation of H1, you're going to put in what. Now, at this point, I will ask the client, okay, what do you believe your correlation will be? And it should be based off of research. It shouldn't be, you're just throwing out numbers because it's Tuesday. You should have done your research to get a sense of what the correlation probably will be given the situation, given that you're introducing possibly an intervention or what have you, okay? And then your alpha criteria, I haven't seen a situation where the alpha wasn't 0.05, but maybe you want 0.01 to be your set alpha, in which case you would just put 0.01 here, okay? You do like that. So, all right. And alpha is your rejection criteria for the null hypothesis. Okay. Your power of the test. People, excuse me, always pick 80%. Some people want it higher, high as possible. So they'll pick 0.95, okay? So you can make this 0.90, all right, but 0.95. And then you're going to hit calculate. All right, so now this is saying that your calculation is a 138. That's what you typically need. Now I tend to, what I'll do is I'll buffer that number by a particular percentage so that if I don't meet my criteria, it's okay because I've put these extra people into the situation. So in that particular part, that comes just from experience over time, just knowing how many to put in there, but you should buffer the number and not too much. Okay. Oh, I'm going to put, 50% more in. No, don't do that. Okay. So that concludes our sample size calculation for a Pearson's correlation. I hope you enjoyed. And I just want to remind people that, at the top of the button, while you can't see it here, there is a save feature where you could save your work and export it out of Gpower and use it for your purposes. It can be a Word document. It could be I think a PDF, and you could just have that for your purposes in case some schools want to see it in the paper, others don't. So that's that. Have a lovely day.